In this video, we are going to see basic algebra. So here we are going to discuss real numbers, absolute value, linear inequalities, some radicals, quadratic functions and logarithms. So first we are going to see a real number system. You know, the number system, the first one is natural number, or we call it as counting number. It starts from 1, 2, 3 and so on, and we denote it as capital N. Then with that, if you add 0 also, 0, 1, 2, 3 etc., that we call it as whole numbers and we denote it as W. Then integers, along with that we take the negative numbers, minus 1, minus 2, minus 3, that is 0, 1, 2, 3 etc., minus 1, minus 2, minus 3 etc., and the whole system we take it as what? Integers, and we denote it as Z. And the next one, real numbers. So here we take rational, irrational, everything together we call it as real numbers and we denote it as R. So real number system consists of rational numbers and irrational numbers. Rational numbers we denote it as Q, later we will see what it is. You know, it is numbers of the form P by Q, where P and Q are integers, and we denote it as Q. You know, real number is the union of rational and irrational. So irrational number we denote it as R minus Q. So from the real number system, if you remove irrational numbers, the remaining numbers are rational numbers. So irrational number system. Irrational number system is R minus Q. That is, from real numbers, if you remove the rational numbers, the remaining numbers are irrational. So irrational number, we don't have a specific letter for that. We denote it as R minus Q. So this is how we denote the number systems. Next we see rational numbers. The lower classes you studied rational numbers. Numbers of the form P by Q, that alone not enough. Numbers of the form P by Q, where P and Q are integers and Q is not equal to 0. Because what happens if Q is equal to 0? Something by 0, it is not defined. So two conditions, numbers of the form P by Q, that is not enough. Both P and Q must be integers and the denominator is not equal to 0. Such numbers we call it as rational numbers. Root 2 is an irrational number. Root 2 you can write it as root 2 by 1, but it is root 2 is not integer. P by Q form you can write, but P is not an integer, so it is irrational number. 1.414, it is rational because it is terminating. Root 2 we assume the value is 1.414, that is only an approximate value. So 1.414 it is rational, but root 2 is an irrational number. Pi is irrational. We have its approximate values 3.14 or 22 by 7. The 3.14 and 22 by 7, they are all rational numbers, but pi is irrational. Remember, 22 by 7 is rational, 3.14 is also rational, but pi is irrational. Now let us see something more about pi. It's an important thing. Pi is a Greek letter and it is an irrational number, and it is proved by Johann in 1767. And how we are calculating pi? Circumference by diameter. Circumference is 2 pi r, diameter is 2r. So if you cancel, you will get pi. So if you take different circles and calculate, you will get different values. It won't be a fixed value, but it is approximately equal to 3.14159265 and so on. So it is not terminating, it is not recurring. That is why we say pi is an irrational number. And the next one, co-prime. There are, you know what is prime number? Prime number means it has only two factors, one and the number itself. But what is co-prime? It has different names. We call it as relatively prime and mutually prime. So co-prime means the numbers, they have nothing common. So there is no common factor among that two. So that is called co-prime. They need not be prime numbers. If nothing is common for that two numbers, we say they are co-prime. Only one is the common factor. Except one, there is no other common factor. Two integers a and b are said to be co-prime if the only factor that divides both of them is 1. So you cannot divide it by any other number. So that is called, that numbers are called co-prime numbers. So remember, they need not be prime numbers. See some examples, 2 and 5. 2 is prime, 5 is prime. 2 and 5 are co-prime. The reason is not because they are prime numbers. The reason is they have no common factor other than 1. So these two numbers are divisible only by 1. You take 3 and 8. 3 is prime number, 8 is not a prime, it is a composite number. But still 3 and 8 are co-prime because they are divisible by only 1. 8 and 9, 8 is not prime, 9 is not prime, but 8 and 9 are co-prime because they do not have any common factor other than 1. So that is co-prime. So co-prime means they have no common factor other than 1. And one more is there, twin prime. You know what is twin prime? Two prime numbers, its difference is 2. So such prime numbers we call it as twin prime. Twin prime, for example, 11 and 13. 11 is prime, 13 is prime, and the difference is 2, and such primes we call it as what? Twin prime. 3 and 5 we can say. So in that case they must be prime numbers and the difference is 2, that is twin prime. Absolute value or modulus value. Modulus x, it has two values. Modulus x, we write x itself if that x is positive, or minus x, that is we change the sign if x is negative. If x is positive, we write the number as it is. If x is negative, we change the sign and write. Then modulus u equal to modulus v. Modulus u equal to modulus v, then u has two values. U is equal to v or u is equal to minus v. For example, modulus x equal to 7, then x has two values, x is equal to plus 7 or x is equal to minus 7. Modulus x equal to minus 6, it is not possible because modulus 6 means, modulus x means it gives the positive value. Modulus x cannot be negative, then we say there is no solution. Suppose they give any inequality like this, modulus of something less than 0 or less than a negative number, it is not at all possible. In that case, you no need to calculate anything, just to say there is no solution because modulus or absolute value is greater than or equal to 0 always. Then some properties, modulus of x into y, modulus x into modulus y, modulus x by y, it is modulus x by modulus y provided y is not equal to 0, and there is an inequality, modulus x plus y is less than or equal to modulus x plus modulus y, modulus x plus y and modulus x minus y are equal only if x into y is equal to 0. And another important thing, modulus x less than r. Modulus x less than r means x must lie between minus r and plus r. X lies between minus r and plus r. Minus r less than x less than r. And modulus x is greater than r means x lies outside minus r and plus r. X is less than minus r and x is greater than plus r. So remember, less than means inside, greater than means it lies outside. Now can you think of a situation where there would be only one solution for an absolute value? You know, absolute value, modulus value of modulus x equal 7 means x equal to plus 7 and x equal to minus 7. Normally it has two values. Only in one case it has only one value, when the value is what? 0. Modulus x equals 0 means x has only one value because 0 and minus 0 both are same. Now we see quadratic function and nature of the curve. So discriminant you study, already in the lower classes you studied discriminant. What is discriminant? Discriminant is b square minus 4ac. Suppose the quadratic equation is ax square, general quadratic equation you know, ax square plus bx plus c, it is a quadratic function. Say f of x is the quadratic function ax square plus bx plus c, and the discriminant is b square minus 4ac. When you find discriminant, if it is positive, we say the roots are real and distinct. In that case, if we draw the curve, how the curve will be? The curve will cut x-axis at two places. It will intersect x-axis at two places. So the parabola intersect x-axis at 2 points. So when the discriminant is positive, that is b square minus 4ac greater than 0, you know the roots are real and distinct. If you draw the curve, the parabola intersect x-axis at 2 points. The second one, when the discriminant is 0, that is when b square minus 4ac is 0, you know the roots are real and equal. The roots are real and equal. In that case, if you draw the curve, the parabola touches x-axis at 1 point. Suppose it is 2 means repeated root, x equal to 2 and 2. So the parabola touches x-axis at one point. And the last one, if the discriminant is negative, that is b square minus 4ac less than 0, then we say there is no real roots. Roots are imaginary. If you draw the graph, it won't touch x-axis. So the parabola does not meet x-axis. So in the first case, when the discriminant is greater than 0, you know the roots are real and distinct. The parabola cuts x-axis at 2 points. If discriminant is 0, the roots are real and equal, the parabola touches x-axis at 1 point. And when the discriminant is negative, that is b square minus 4ac less than 0, the roots are imaginary, there is no real roots, then the parabola does not touch x-axis. Okay? That is the nature of the curve. Now let us see quadratic equation. You know quadratic equation means degree 2, it has 2 values. And one important thing, irrational roots occur in conjugate pair. You know what is irrational root? 2 plus root 3. It is an irrational root because root 3 is an irrational number. It occurs in conjugate pair. So 2 plus root 3 is a root means 2 minus root 3 is also a root. If a plus root b is a root b is an irrational number, then a minus root b is also a root. So remember, irrational roots occur in conjugate pair. Root 5 is a root means definitely minus root 5 is also a root. 7 is a root, you cannot say minus 7 is a root. Only irrational number occur in conjugate pair. Now some of the results what is studied in the lower classes, alpha plus beta, it is minus b by a, alpha into beta, c by a, 2 basic results. Then alpha square plus beta square is alpha plus beta the whole square minus 2 alpha beta. Alpha minus beta the whole square is alpha plus beta the whole square minus 4 alpha beta. We use all these in many places, so remember these values. Then how to name an equation? Suppose the degree is 1, we call it as a linear equation. If the degree is 2, we call it as quadratic equation. If the degree is 3, it is called cubic equation. If the degree is 4, it is called quartic equation. If the degree is 5, it is called quintic equation. So these are the names of a equation. So by giving an equation, they can ask to name it. Okay, for objective question, they can ask these things. So remember this. Now you see division algorithm. In the lower classes, you studied for numbers. For example, 17 if you want to divide by 5. You know the quotient is 3. 5 3s are 15, the remainder is 2. So 17 can be written as 5 into 3. 5 into 3 plus 2. And the remainder 2 is less than this 5. Remainder 2 is less than 5. Remember two things. 17 is equal to 5 into 3 plus 2. 17 is equal to 5 into 3 plus 2. 2 is the remainder. And the remainder is less than 5. It can be 0. It can be 0 and it must be less than 5. Same thing, here we take two polynomials. Say f of x is a polynomial, g of x is another polynomial. So two polynomials given, f of x and g of x. F of x we are dividing by g of x. F of x we are dividing by g of x. You will get a quotient q of x and the remainder r of x. Then you can say f of x is equal to g of x into q of x plus r of x. F of x is equal to q of x into g of x plus r of x. R of x is the remainder and its degree is less than degree of g of x. Degree of the remainder is less than degree of g of x, and this is division algorithm. Next, how to solve inequalities graphically. It's a very important thing, so listen. Suppose they say x is less than 2. X is less than 2. So 2 is not included, x less than 2. In a number line, minus x is less than 2. You know, 2 is here. So less than 2 means its left side. 2 is not included. So don't shade this one, its left side value. So minus infinity to 2. Minus infinity always use open interval, and here 2 is not included, so that is open interval. Okay, that is the graph of x less than 2. Now see, x is greater than minus 2. X is greater than minus 2. Minus 2 is here. Minus 2. Greater than minus 2 means its right side, and here also this minus 2 is not included because x is greater than minus 2. Now see the next one, x less than or equal to 1. x less than or equal to 1, less than or equal to 1, so closed interval 1, x less than or equal to 1, so 1 is here, 1 is included, x less than or equal to 1, so 1 is included, less than, so its left side values. Okay, so this is x less than or equal to 1. Next you see x greater than or equal to minus 3, x greater than or equal to minus 3, minus 3 is here, greater than or equal to minus 3, so minus 3 is included, greater than, so its right side values. But when you draw in the in a paper, you cannot shade like this, so you can shade in this way, okay, and you can shade like this and you can darken this point, okay, like that you can do it. So that's all about the inequalities. You know, one important thing, inequality reverses. When the inequality reverses, only in two cases the inequality reverses. When you multiply or divide by a negative number, the inequality reverses. And when you take reciprocal, in this case also inequality reverses. For example, you know 2 is less than 4. When you multiply both sides by say minus 2, or I multiplying by minus 2 both sides, so you will get minus 4 and minus 8. You know minus 4 is greater than minus 8. So when you multiply by a negative number, the inequality reverses. And another case, 2 is less than 4. You take reciprocal of 2 is 1 by 2. Reciprocal of 4 is 1 by 4, you know 1 by 2 is greater than 1 by 4. So in these two cases inequality reverses. But when you multiply by a positive number, there won't be any change. Then logarithm is a very important thing. Logarithm and exponential function both are inverses. So inverse of a logarithmic function is exponential function, and the inverse of exponential function is logarithmic function. And you must know how to change exponential form to logarithmic form. Suppose y is equal to a raised to x. When you change it into logarithmic form, log y to the base a equal to x. Log y to the base a. Log y to the base a is equal to x. Same way, how to change logarithmic form to exponential form. Log a to the base b equal to c. You start from the base, just you cross it. b raised to c. b raised to c is equal to a. So like that, exponential to logarithm and logarithm to exponential. Some other values in logarithm, you remember, log 1 to any base it is 0. Log a to the base a, if these two are same, the answer is 1. Log 10 it is 1. Log 0 it is minus infinity. Log a to the base b, you can interchange this a and b, but you write 1 by. Log a to the base b can be written as 1 by, you can reverse it, log b to the base a. And some of the rules in logarithm, you know, product rule, log a plus log b equal to log of ab. Remember, the base must be same. Log a plus log b is log of ab, that is called product rule. Log a minus log b is log of a by b, that is called quotient rule. When plus comes, it is product, minus it is division. This is product rule, this is quotient rule. In both the cases, the bases must be same. And the next one is called power rule, log a raised to x. The power will come from log a to the power x is x log a. The base remains same. The power will come from x log a, and you must know how to write in the reverse order also. Then the next one is base changing rule. That's very important thing. Log a to the base b. Suppose you want to write, you want to introduce the letter c. You write the log 2 times. Write log 2 times. The letter what you want to introduce, the new letter, either you write in these two places or write in these two places. So can be written in two ways. Log a to the base b, you write as a product of two logs. The letter what you want to introduce, you write here. In a cross way you write c, c, or you write these two places like this also. Other places you fill here, already c and c you written here, a you write here, and b is the base, only here you have place. In this case, c introduced here. Now a you write here and the base b you write here. And from here, how to write this, that also important thing. Listen, the cross you see, the c and c get cancelled. What you get? Log a to the base b. You can write like this, and this is called base changing rule. Here also, from here, how to write this? Here c, here also c. That leave it. What's the remaining? Log a to the base b. Okay, like that you can write that. And that is called base changing rule. And the domain of logarithmic function is 0 to infinity. Logarithm of a negative number is not defined. So, domain is 0 comma infinity and the range is minus infinity to plus infinity. Logarithmic notation, there are two types of logarithms. Common logarithm, it is with base 10, that is we write it as log x. Remember, the base is 10, that is common logarithm. If the base is e and we denote it as ln x, base is e and that we call it as natural logarithm. So, there are two types of logarithm, common logarithm and natural logarithm. And the difference is, for common logarithm the base is 10, natural logarithm the base is e, and how we denote it, and you must know how to convert it. Ln x, that is natural logarithm, you can convert it into common logarithm by multiplying it by 2.303. So, ln x is equal to 2.303 into log x. In our next video, we will see MCQs from this topic. Thank you.